It's a running joke among software engineers how difficult it is to escape from Vim, which is fair. It can take a few keystrokes to actually navigate out. Now, like a lot of Vim users, I actually make this even harder on myself. I started using Vim a couple years ago when I was dealing with wrist pain from typing on the computer all day. Vim lets you do a lot more of your text editing work directly from the keyboard, and that helped me a ton. But it is also not without its problems. One of the biggest ones is needing to reach up for this escape key frequently. Not only is it slow, but it's a weird motion for your wrist to be doing all the time. So like a lot of people, I remapped the escape key to something else. Instead of hitting the escape key, I hit J followed by K in quick succession. This is a super cool thing built directly into Vim. You can use the command imap_jkescape and you're all set up. This is why I'm a big fan of Vim. It lets me keep typing without any wrist pain. And that's why I was so excited when Apple announced Vim support for Xcode 13, and then so disappointed when I learned that it did not allow customizations like this. So when Xcode 13 was still in beta, I spent some time reverse engineering this new Vim mode and figuring out how to make an Xcode plugin to add this JK escape sequence back myself. If you haven't run into them before, old school Xcode plugins are super cool. They're little bundles of code that hook into Xcode internals to change whatever functionality you want. They started popping up around Xcode 3 or 4 and they were semi-officially supported by Xcode. Like, I'm not sure if they were ever actually documented anywhere, but you could put these plugins in a specific folder in your user directory and Xcode would load them, check for compatibility, even show a little pop-up the first time you launched one to make sure you were doing it intentionally. And this was great. There was a thriving plugin ecosystem, and with a little bit of work, you could customize Xcode however you wanted. Xcode 8 made plugins a lot harder to use. Apple had enabled library validation on this version of Xcode. This is an OS level feature that prevents apps from loading arbitrary third-party code, like plugins, and it mostly killed off the Xcode plugin scene. But they were still possible to make and to use. You just had to disable library validation by re-code signing your copy of Xcode, which people who still use Xcode plugins have been doing for years, myself included. So when I wanted to add this new functionality to Xcode where this JK escape sequence that I'm used to would work, making an Xcode plugin was no problem and basically the only way to go anyways. I wrote a long blog post about it over on bryce.co. I'll put a link around here somewhere. But it works in a similar way to most other Xcode plugins, by hooking into some internal Xcode functionality in order to change its behavior. In this case, that's the editor's code that's responsible for handling key presses. It then figures out if we're currently in Vim mode, and if so, watches for a JK key press and simulates an escape key instead. It has the normal Xcode plugin downside of needing to re-sign your copy of Xcode, but the overall end result is that this has made Xcode way more accessible to me, and I can now edit code without having to worry about wrist pain. Overall, for me, this is a nearly perfect system. Apple had clearly signaled that plugins were on the way out, and in Xcode 14, Apple removed plugin loading entirely. Even if your copy of Xcode has been re-signed to remove library validation, plugins still won't be loaded. Apple is usually great at accessibility features, and plugin support is, in my mind, an accessibility feature. So given their ongoing commitment to accessibility, I'm sure they won't mind if we just add plugin support back in ourselves. So let's do that. Our goal is to mod Xcode so that it performs the same behavior that it used to, looking in a directory for plugin bundles, loading them into memory, setting them up however they need. The idea is that we can take existing Xcode plugins that are already built and get them to work on newer versions of Xcode, including my Vim remapping plugin. We need to start with the ability to inject some code into Xcode. Let's start with a common way of doing this, which is to create a dynamic library that contains the code we want to run. So I'm going to go ahead and open Xcode and create a new project. We'll use the Mac OS library, and I'm going to call it Xcode Plugin Loader. And importantly, we want the type here to be dynamic because we're going to be loading this library at runtime. Now we're going to start with a single file here, and I'm going to go ahead and create a very basic function that just prints out a log statement so that we can know our code injection is working. Now one last thing we have to do, we have to mark this function as a constructor to tell the compiler that we want it to be run whenever this library is loaded. And with that we can build, and then we can go up to product, show build folder in Finder, and find our dynamic library here. Now with a simple setup, if you had an app that you wanted to inject code into, like let's say you have a basic Hello World application, when launching that program you could use dyld insert libraries, just an environment variable, and we're going to go ahead and pass in the path to this dynamic library, and then we can launch this program just the same as before, and now we'll see two log statements. We have our original Hello World, but now we also have this injected log that we added right here. So that's a very quick and easy way to get code injection working. Now we have one big problem here, which is that if I try to do the same thing with Xcode, we'll see Xcode's normal logging, but we won't see that injected message at the top. And that's because of that library validation functionality that we talked about earlier. So what we need to do is open our applications folder, and I'm going to go ahead and make a copy of Xcode, literally just copy paste. One important thing to note, Finder is showing that this new copy is taking up an additional 12 gigabytes of space on my machine, but that's mostly a lie thanks to APFS cloning. macOS has basically just created a bunch of duplicate links to the same underlying data on disk, so we don't have to worry about that. I'm going to go ahead and rename this copy to indicate that this is the one that we want to be able to load plugins in. And now I'm going to re-sign it using my own certificate. So I'm going to go ahead and open Keychain Access, and I'm going to go up here to Keychain Access, Certificate Assistant, create a certificate. And we can name this basically whatever. I'm going to call mine self-sign, and we're going to say that this certificate is for code signing. We're going to go ahead and create it. Keychain Assistant is going to say, hey, this isn't overly useful as a certificate, but it works for our case. We can go ahead and hit continue and then done. And now back in terminal, I'm going to go ahead and use that certificate to re-sign our new copy of Xcode. And now if we try to do the same sort of code injection as before, but we use our new re-signed copy of Xcode, we can see the very first log of this output is that injection message. So with this change, we're able to load arbitrary code into Xcode. Now again, this is the same process that people have already been using to load Xcode plugins for years, but there are some big downsides, so that's worth talking about right now. The main issue is that to the rest of macOS, this no longer looks like the official Apple-provided Xcode release, because we've removed Apple's signature and lost all the entitlements that they added. And while most of Xcode still works perfectly fine like this, you might see issues in places where Xcode communicates with helper processes. For example, if we go up to Xcode settings and look at the accounts tab, you'll see that it's having trouble connecting to my Apple ID, and if I try to sign in again, we get this issue that it couldn't communicate with some other system helper. So not having access to your Apple ID means things like automated signing won't work, and there are other issues too, like Swift UI previews won't work. Again, you're used to this if you're using Xcode plugins already, but worth calling out. There is actually another option because library validation is enforced by system integrity protection, which if you've tried to do anything particularly interesting on your Mac in the last few years, you're already familiar with. This is a collection of macOS protections that prevent things like modifying processes, for which Apple provides a guide on how to disable it if you want. Disabling system integrity protection does weaken the security of your machine, so most people just recommend re-signing Xcode for plugin use. But honestly, it depends on your use case. Like I always have SIP enabled on my work machine, but I often have it disabled on my personal machine, in which case I get the full Xcode experience. But I don't have to manage my app certificates often, and I basically never use Swift UI previews, so it's not too much of a burden for me either way, but just calling it out so that you can know the right trade-offs for you. But as long as you don't really need the couple features of Xcode that are going to be broken, just re-signing Xcode's probably the way to go. Now, with all that said, given we can actually inject code now, let's look at building a more proper plugin system. So I'm going to start by creating an actual Objective-C class to manage most of this logic. And I'm just going to match the name of the project here. We'll call it Xcode Plugin Loader. And let's create a method to actually load these plugins. So as mentioned before, there's a fixed path that Xcode used to look at to load these plugins. If I open that directory on my machine, you'll see that I actually have my old Xcode plugin here. So we're pointing to the right place. Now I'm going to get the full expanded version of that path. And now I can ask NS File Manager for the contents of that directory. And let's go ahead and just print out whatever value we get for that. And now let's relaunch Xcode with this attached. And now one last thing, we need to update our main file to actually call this function. So I'm going to import the header for this class, and then create a new variable to hold an instance of it. And now we're going to create an instance of that class, and tell it to start loading plugins. Now let's build succeeded. So I'm going to go ahead and run Xcode again with all these changes. And here we go. So we have our injected log, same as before, and now we can see that Xcode is seeing this Xcode Vim Map XE plugin, along with a DS-store file because we opened this directory in Finder. Let's go back to our main implementation file, and instead of printing out the contents of this directory, I'm going to go ahead and iterate through it instead. Now these XE plugin files are just bundles. If we look in Finder again, we can right-click on one, do show package contents, and we can see what's inside, which in this case is not much, mostly just a binary. So I'm going to start by collecting some basic metadata about the items in this directory. I'm going to add a quick check to make sure that extension matches XC plugin, and then I'm going to call nsBundle bundle with path to attempt to load a bundle from the absolute path of whatever item we're looking at, along with some basic logging to help us track progress. Now I'm going to go ahead and build again, and then we'll come over here and launch Xcode again, and I'm going to temporarily make this a bit bigger so we can read better. We have our injection message, and then we say we attempt to load Xcode Vim Map, and we don't have any errors printed out, but let's check the actual result. We have two copies of Xcode open now. We have our original unmodified one that we're using to make the plugin loader, and then we have our modified one with code injected into it. So I'm typing text now, and if I hit JK in quick succession, what we want to have happen is for that to be treated as an escape key, which would look closer to this. But that didn't work. And if we look at the source code for this plugin, we can see why, which is that everything is kicked off from this one plugin did load method. This is something that Xcode's old plugin loader would call for us. So that's an easy fix. First, we're going to ask the bundle for its principal class, which is basically the main class of the bundle. It's something that bundles can specify as part of their info plist. And then I'm going to call plugin did load on that class, and it took an NSBundle parameter, so we're going to go ahead and pass that bundle in. Now, Xcode's going to complain that it has no idea what this plugin did load method is. So I'm going to go ahead and create a new header file, and I'll call it Xcode plugin. We don't provide an actual implementation for this interface. There's no class called Xcode plugin as part of this project. We're just saying that there exists some object that has this method plugin did load. And if we go back to our plugin loader implementation and import that new header up here, then that warning should go away. Perfect. Now, one more thing for safety. This is a method that Xcode did call for you previously, but I don't actually know if it was a required method on all plugins. So I'm going to wrap that call within a check to make sure that that class actually responds to that selector, that they actually implement that method. If not, they might be be doing all their work in a constructor like the kind we're using in our original file, and that's fine too. So I'm gonna go ahead and build, and we're gonna go ahead and run this again. We have a lot more output this time, including output from the Xcode VimMap plugin. These are log statements that are added in the source code for that plugin. So I'm gonna go ahead and open another test project. And this time, if I add some more text and then I hit JK, that is absolutely beautiful. I wish I had a camera pointed at my hands right now, but hopefully you can see my absolute joy for not having to reach up for that escape key. So perfect, we have a working plugin system again. This is awesome. But there's still a couple things that are stopping this from being as close to Xcode's original plugin loading system as I would like. One big one is compatibility checks. Every version of Xcode has an internal ID called a plugin compatibility UUID that plugins can use to say that they've been tested with and are compatible with that particular Xcode version. Like, let's look at an example. You can read an Xcode version's plugin compatibility UUID using a defaults read command like this, and you'll get a UUID printed out. Now, if I go to my plugins directory and we look at this Vim remap plugin that we're using, we can right click to show package contents, and then inside of here is an info plist file. If I open that with a text editor, we can scroll down and see that we have an array called DVT plugin compatibility UUIDs that has a list of all of these IDs. The first one in this particular list was the ID used by Xcode 13.4. This next one was used by 13.3, and so on. So this is the plugin's way of saying, hey, somebody tested and confirmed that I worked with Xcode 13.4, and they added Xcode 13.4's ID to this list as a result. So if I go back to terminal, we can see that Xcode 15.2, the version we're using, has this particular ID, and this ID is not in this list, which Xcode's original plugin loader would interpret to mean this plugin hasn't been tested and shouldn't be loaded. And this is a good system. It exists because these plugins tend to rely on Xcode internals that are not necessarily stable across versions. You don't want some plugin hooking into some internal function that no longer exists after an update, so you need some way for that plugin to be able to say what versions of Xcode it's been tested with. But this does mean that based on Xcode's original loading system, this plugin shouldn't be loaded in Xcode 15.2. So let's see if we can add support for that functionality. So I'm going to start by asking our plugin bundle for its info plist value of this particular name, which is the same name we saw at the beginning of this array. And ideally we get an array of strings back, but I'm going to add a basic compatibility check to make sure that we have the right type we expect here. And with this, we'll have an array that corresponds to all those different values that the plugin specified. And we're going to want to look through each one and see if it matches the ID specified by whatever version of Xcode we're running. And we know that we can get this information by using this defaults read command, but I don't really want to run a shell command from this Xcode plugin loader to get this info. Like, this code is being run within Xcode's process, and I assume Xcode has some way to get this information itself. So let's see if we can figure out how it gets that info normally. One way we can do that is to download an old copy of Xcode that did have plugin loading, like Xcode 13. Because if the plugin loading system that was built into Xcode did the same check itself, it has some way that it can access this ID too. So I'm going to go ahead and copy this string, and over here in terminal I'm going to cd into our Xcode 13's application directory, and I'm just going to go ahead and search for that string. And we see a ton of results, mostly info plist files, and that's because Xcode also uses plugins internally, and all of those plugins specify their own compatibility information. So that's not what we want, and I'm just going to go ahead and exclude those plist files from the results. And it looks like we get a couple actual results, but the first one is this dvt foundation.framework, and the string we're looking for has a prefix dvt, so this seems like a reasonable first place to look into. So what I'm going to do is grab the path to the directory containing this binary. I'm just going to go ahead and open it in Finder, and then I'm going to open it disassembler. I'm using Hopper, and I'm just going to drag that binary in there. All these defaults are okay with me, and we'll need to give it a second to parse through everything. But now what we can do is go back to Xcode, and we're going to copy this string that we're interested in, and back to Hopper, I'm going to make sure I'm in the strings tab, and I'm going to search for that string. So it's defined right here at this address. I'm going to go and see what places reference this address, and I'm expecting at least one, a CF string. So CF string is basically a wrapper around like a normal C string character array, so this makes sense. But let's see what places are referencing the CF string. And we have one, DVT plugin scan record, load required capabilities. Interesting. I'm gonna go ahead and look at the decompilation for this method, and that's very small. I'm gonna move it out to Sublime. And searching through this, I can see one or two places that are referencing these UUIDs. I would guess this is on the plugin loading side, where we're iterating over the collection of UUIDs specified in our plist. Like, we get the count of some collection, and then we loop over it, we create UUIDs. But I don't see anything in this method that's referencing Xcode's plugin compatibility UUID. We can dig more through this, but I also want to look at other results here. Like, there's this one called DevTools Core, which seems interesting. So I'm gonna make a new Hopper instance and look through that one real quick too. I find it's useful to cast a pretty wide net before wasting time digging into any of the specifics. So same thing, I'm just gonna search for that string from Xcode. Oh, this one actually has two references to that string. We've got just the string key itself, and then we've got got some sort of log message, required plugin compatibility, not present. This sounds perfect. This looks like the code that's actually responsible for checking if Xcode's compatibility UUID matches what's specified in the plist for our plugin. So I'm going to look at that one first. And same thing, I'm just going to pull references to that. We're going to go through the C screen here. And looking at the decompilation of this one, this is a method on Xe plugin manager called find and load plugins. Seems perfect, and we've already seen that there's this log message referenced here when the UUIDs don't match. So I'm gonna, again, copy this out to Sublime. And just searching for UUID in this file, the first result is a thing called plugin host UUID. I assume Xcode is the plugin host, so that might be how we can actually get the ID we're looking for. I'm going to copy this method name and I'm going to go back to Hopper, and I'm going to switch over to the labels tab, which lets us search through method names. And I'm going to search for plugin host UUID. And we have this class Xe plugin manager plugin host UUID. That sounds like what we might want. So I'm going to go ahead and look at how this is implemented. And this looks perfect. We're calling DVT plugin manager default plugin manager. And then on that object, we are calling plugin host UUID. If this is what we are looking for, then this is super nice, because then we don't have to worry about getting an instance of a plugin manager. There's just this class method that'll give us a shared one. Now, to make sure this is the right method, I want to attach the debugger to Xcode so that we can call the method and see if it matches the results we found from that default read command. But if we try to attach the debugger to Xcode 13, which is the version of Xcode that this decompilation came from, then I expect we're going to run into an issue, which is that I have system integrity protection turned on and LLDB is not going to let me debug this executable. And that's what happened. But we have another option here, which is to attach the debugger to the re-signed version of Xcode we made earlier, because that has hardened runtime protections removed. That works off the assumption that this method still exists in Xcode 15, but we want that to be the case anyways, because we want to call this from our plugin loader. It's going to take a while to actually get booted up. And now I'm going to hit Control-C to stop the process, and we're going to call plugin host UUID on that shared manager that we saw. And perfect, we get a UUID out, and this was the same UUID that we saw in the default read command earlier. So I'm going to copy this and move it over to our plugin loader, and we'll create a new variable called Xcode UUID and set it to this value. Now Xcode's going to complain that it has no idea what this class is or any of these methods. But just like before, we can create a new header file that represents that class. I'll call it dbt plugin manager.h because that's the class name, and I've created a basic interface that has the methods we expect on it. One class method that returns the shared manager called default plugin manager, and one instance method that actually returns the UUID. Now over here, we'll import the header and the error message should go away. Just to make sure we have everything correct with the call, I'm going to print out that UUID value. Now, when I try to build this, we actually run into an issue, and that's from the linker complaining that we're referencing a class that it can't find. So to work around that, instead of referencing this class directly, I'm going to create that class from a string value. The linker doesn't have to care about it. So now if we build, everything works, and let's go ahead and launch Xcode. Now expanding this out again and looking at the logs, we can see that we're actually missing our UUID value, that we're getting null back. And the reason for that is due to a kind of common issue with this sort of code injection setup, which is that this plugin loader library that we made is being loaded before the library containing this DVT plugin manager. So when this line of code is run, this class doesn't exist yet, which even besides getting this UUID is another issue with our current setup. Xcode's existing plugin infrastructure would load plugins after everything else had already been instantiated. But with this setup, we're loading things immediately, which might break some assumptions in existing plugins. So to fix that, I want to make something that waits for this class to exist before we do any of the setup. So I'm going to go ahead and create a new class, and I'm going to call it a class load observer. And I'm going to start by giving it one class method where you can pass in an array of classes that you want to wait for, along with a completion block to be invoked when those classes are loaded. The idea being that in our main plugin loader implementation, we can create this class load observer and we can say, hey, we're interested in this one class. And once that class is loaded, call out to this load plugins method that we already built. So I added the start method to kick that off. So I'm going to go back to our constructor. I'm going to call start instead of calling load plugins directly. And now this looks good, other than class load observer needing to exist. So let's build that out. I'm starting with an empty class implementation that matches the header file we made. Now I'm going to add some properties to store the info we were passed in. In the implementation of this class method, I'm just going to make call out to an initializer that does the actual setup. Now the goal for this class is to call whatever's in this completion block whenever all the classes in this classes array have been loaded into memory. So the first thing I want to do is call a method to figure out which of those classes already exist in memory. If they all exist already, we can just call our completion block. And the implementation of that is pretty straightforward. I'm going to create a mutable set to hold all the classes that we're interested in that are loaded already. And then I'm going to iterate through all of the classes that we're given, check if that class exists, which I'm going to do by calling nsClass from string and passing in the class name and seeing if we get anything back. If we do, we know that class has already been loaded into memory. And if it is already loaded into memory, we can just go ahead and add that class name to our set of already loaded classes. Now I'm going to take the set of all classes we care about and I'm going to remove everything in that list of already loaded classes. And the end result after that line is that anything in this remaining classes set is going to be a class that we're interested in but hasn't been loaded into memory yet. So if there's nothing in there, we can just call our completion block already. But if not, we're going to have to wait for those classes to be loaded. And we can do that using NS Notification Center. There's a notification called NS Bundle Did Load notification that's called whenever a bundle is loaded into memory, including a bundle containing code. So here I'm just going to call out to another method to process whatever new classes have been loaded. Now there's a way to look at just the classes that were loaded as part of this new bundle, but I found that there can be some tricky race conditions when the bundle you're interested in is loaded at roughly the same time that you're making this notification, which could be the case here. So instead of looking at just the new classes, I'm just going to have a very similar setup to before where we go through all the remaining classes that we're interested in, we knock any out of the set that are loaded, and then if we've gotten rid of all the classes that we're waiting for, we call our completion block. And I'm going to add one more check here to make this whole thing a no-op if we already have gotten rid of all of our classes, because we don't want the completion block called multiple times. There's more we can do to clean this up, but I think this should work for now. So let's go ahead and build and then run again. And this time we can see the right UUID is printed out. So we are successfully waiting for this class to load now before doing all our plugin setup. So now I've added some code to check the UUIDs given by our plugin and see if any of them match the one given by Xcode. The actual implementation isn't super interesting. There's some basic safety checks, and then we are iterating through those UUIDs and seeing if one matches. But if I build now and then restart Xcode, what I'm hoping we see if we go up to our plugin loading is that we're skipping Xcode Vim map. Perfect. Because this is an old plugin, we saw it only had UUIDs for Xcode 13.4 and earlier. So our plugin loader can now see that this plugin hasn't been explicitly approved for Xcode 15.2. Now let's do this. I'm going to copy this UUID and I'm going to add a new entry for Xcode 15.2's ID because we tested it earlier when we didn't have this compatibility check and we saw that it worked fine. So I'm going to save this. Now I'm going to relaunch Xcode, and what we should see this time is that our plugin loader determined that this plugin was compatible and it actually loaded it. And now if we open an Xcode project again, it works. So now our plugin loader can handle compatibility checks the same way that Xcode's plugin loader did it. And it doesn't load plugins until at least some core part of Xcode's infrastructure has loaded itself. And with that, we've modded plugins back into Xcode. Everything is correct in the Xcode world again. Jesus Christ! As of me recording this, Xcode 15.2 is the latest released version of Xcode. And that's what we've been testing with the whole time. But the 15.3 beta is out, and it comes with this fun quirk, which is that it has no concept of this plugin compatibility ID. We can confirm this locally. If I run the same defaults read command that we were using earlier to find the ID, it returns no data for this version of Xcode. And if we try using our plugin loader on Xcode 15.3, we see that it's not just an issue with that command, our code also can't read the UUID anymore. Which makes sense. Apple's been slowly getting rid of this plugin system. They don't need the concept of this ID. This is luckily a solvable problem. We just need some way for a plugin to communicate that it's been tested with a given Xcode version. What I'm going to do is I'm going to open Xcode's info plist, and I'm going to see what data in here we might be able to use instead. One obvious one might be to use the actual version of Xcode itself, like 15.3, or this numerical version, 1530. But there's two downsides with that. One, this is a beta version of Xcode, and that's not reflected in this version number. Plugins can and do break between different beta versions of Xcode. So we really want a version number that can change between different betas. There's another downside here too though, which is that this number is predictable. I think there's a reason why Apple went with the very random looking UUID before, and that's that if you use a predictable numbering scheme, it makes it possible as a plugin developer to just list all future Xcode versions and say your plugin's compatible already. And like, don't get me wrong, that sounds really nice as a plugin developer. Like, it's kind of annoying to pull down the latest Xcode version and add the latest ID, but I think that system's way better for users because otherwise it's way too easy as a developer to just list all future Xcode versions, and then as a user you update Xcode and suddenly everything's crashing because of some compatibility that wasn't actually tested. So for both of those reasons, I'd rather look at a more complex build number like this one. There's one other important note that comes with this though, which is that I believe Apple can release multiple builds of the same Xcode version. Like, this is Xcode 15.3 beta 1, and I have this build number ending with an E, but if we look at Xcode releases, they got a build number ending with I. Otherwise completely the same, just a small difference with the letter at the end. So what I would like to do is allow plugins to specify something like the first part of the string. And by default, that would mean they were compatible with either this version or this version. Alternatively, they can specify the full version number with the letter at the end to say, No, I really mean just this one particular build. So I've gone ahead and updated the plugins info plist file with this new section, build compatible versions, where we have this version representing 15.3 beta 1 and this one representing 15.3 beta 2. And I've updated the plugin loader to account for this new setup. We have the same compatibility check as before, but now there's an additional one above it that checks this new build version system. So the loader will use this system first and fall back to the old system if needed. And again, the implementation isn't super interesting here. We're just iterating through all the build versions specified in that plist. We check if any of them are equal to Xcode's build version, and if so, we treat it as compatible. And we also have support for kind of fuzzy matching the first part of the version number if the only difference is lowercase letters at the end. And now if we launch the 15.3 beta again, we can see that our plugin loader did determine that this version was compatible and actually loaded the plugin. And just like before, if we try to use it, works perfectly. Now there's still a couple things that make this different from Xcode's original plugin loader. One big one is that since it's not built in, we've had to inject it into Xcode every single time. That's obviously annoying, so what I'd recommend doing instead is using optool, which lets you modify a binary to say always load this additional framework. So I'm going to run this command to update my Xcode 15.3 beta to say always load this plugin loader. And it says it successfully inserted the load command. Now all I need to do is grab a copy of this actual loader, and then I'm going to open my copy of Xcode, and I'm just going to paste it in this contents directory, and I'm going to remove this prefix to match the command I sent earlier, and now I can open this copy of Xcode just like any other version. Now there's one more big difference to watch out for when comparing this system with Xcode's old plugin loading, which is that plugins now need to follow the same rules as other bundles on macOS. All of this ran fine because the plugin we were using, that Vim remapping one, came from my own machine. But if I had just downloaded that from the internet, we might have gotten some complaints in the logs about loading an unsigned bundle. It's a pretty easy fix though. As a user, you can just tell your system that that plugin shouldn't be quarantined using a command like this. Or as a plugin developer, you can notarize your plugin the same way you would with other types of macOS software. Notarization is possible even for Xcode plugins. I've actually updated the public release of this Vim remapping plugin to include a notarized build that people can download. And last but definitely not least, if you're keeping both modified and unmodified versions of Xcode on your computer, like how I have these plugin and non-plugin variants of Xcode, one thing I found useful is to go into the get info pane for these. And the thing I didn't realize for a while, you can actually just drag a new icon onto here and macOS will handle the update for you. So now you can have a clear visual difference between the two, which is useful for making sure you're opening the correct one, especially from a small context menu. But anyways, I think that's it. It's getting dark here, so I should probably go do something else. But I've put the source code for this project and a precompiled binary up on GitHub. So if you're one of the people that's also desperately missed plugins since they were removed, then I hope you find this useful. But either way, thank you so much for watching. If you watched all the way to this point, you clearly like this kind of nonsense, so remember to subscribe, and I'll see you for the next one.